Hi, in this video I'm going to take you through the operation risk part for the FRM Part 2 exam. I have broadly divided the session into 8 topics, starting with economic capital modeling, which is about the risk adjusted return for a bank. Then we have the model risk, which talks about the general errors in the models that we are assuming in different types of parametric approaches. Then we have the liquidity risk, which is one of the biggest risks which came into existence after the 2007 crisis came into being. So that was a time when liquidity was lost. So understanding liquidity risk is another very important part. Then we have enterprise risk management, which takes care about the risk for the entire business. Then we have the risk from lost data, which is a little bit typical. And the sixth part, which I have put in red, is analyzing these risk from the operation loss from these risks which are there because of loss of data. So this is a little bit new, and because we have got new databases and new things that are coming in operation risk specifically related to loss of data. So that is something new, interesting, a little bit quant and a research level thing. Then we have the dealer banker, or the kind of investment banks that we have. Then we have the BASEL norms and risk aggregation, or adding all these risks. So a disclaimer that FRM is copyright to GARP Institute. This video is intended for research. I don't represent FRM Institute. So my idea is to give you an overview about the operation risk part and sensitize you with various topics. Now, economic capital modeling is divided into two parts here. First is calculating the risk adjusted return for a bank, which is given by this formula: revenue minus expected loss minus expense plus return on economic capital minus transfer price upon economic capital. So this is the return. Now when we talk about adding up all these risks to find out the kind of expected loss that we can see, we have two methods out of 5 methods which are important. So those two are variance covariance method and copula, which combines marginal probability into joint probability. If you are not knowing about this copula, it's like if you have x and y as two arrays that you want to find out the correlation, but when you take log x and log y, the correlation is different. So even if x and y are correlated, we get something like log n and log y, which we are trying to use in the formulas. So this copula combines these marginal distributions to find out a joint marginal probability distribution, which is a kind of a multivariate thing. This is more about high-fi quant, which is again discussed in the market risk part. Then we have two new measures which are though not used so much frequently for risk aggregation. That are the distorted risk measure and Spectral. You can check them out from the Wikipedia. The thing that is known to all of you and that is used is the simple covariance matrix, which you can see on your screen. So this is a kind of covariance matrix which is quite similar to the covariance that you study. Okay, then the next part we have is the model risk. So various models we are using might be having unknown parameters, might be having correlation. We will be mixing those parameters and mixing all those distributions. So these kind of risks exist in the model risk. Okay, when we have an unknown parameter, especially in normal distribution, we use the chi-square distribution. Just check that out. So the most important and the heart of this operational risk part is the liquidity risk, because whenever there is a crisis, the first thing that goes out of the global economy is the liquidity. So this is one of the most important risks. And then we have the funding risk, again on a macroeconomic perspective. That risk can be understood by Gini coefficient and Lorentz curve. Both of these talks about the spending power of common people. It's like most of the wealth is being held by the top 10% and least held by the bottom 10% and things like that. So it's about funding part. Now liquidity risk is, as I told you, the most important part, and the most challenging part here is quantifying that liquidity risk. So we have the bid-ask spread. So one aspect is to calculate the mid value of the bid-ask spread, and higher the spread, the higher the risk would be, and include that thing in our liquidity adjusted VAR. Then we have something called the stochastic spread, which we can calculate. So that would depend on time, and we'll assume that okay, the spread moves in a geometrical Brownian motion and things like that, something like the Black-Scholes. Then we have two types of prices: endogenous and exogenous prices. Exogenous prices means the prices are not affected by the trades that you do. But in case of endogenous prices, the prices do get affected when you trade. So you are having a big position in the market or in that stock that you are going to sell at some point of time, and your prices are going to affect the prices. So in that case, we use this elasticity term to find out the liquidity adjusted VAR. So we calculate that elasticity, and we find out how much the prices are going to move due to this elasticity effect. Okay, this is something tricky, but you don't need to go into a lot of quant. So there are some distribution used for operation loss. To be specific, they are most often seen in the data loss, which includes exponential distribution, Weibull, gamma, log normal, Pareto. Now there are a lot of cases on how and when to use these distributions. In a generalized way, these are something related to the extreme value theorem. Okay, coming to a part that is big and challenging and has become relevant again is the loss of data. Now you know that the information systems are quite complex and interrelated. So there is a great chance that loss of data might occur for a bank. And to understand this loss of data loss, you have to get the data from all the banks, find out the severity and the frequency of these kind of losses due to loss of data and things like that. So we generally use peaks over threshold and generalized Pareto distribution for them. That's just a theoretical part. And there are various risks which are associated with this risk from loss of data. So this is something about that. And then we move on, and then we have the tail plots and the mean axis plots, and those are like the fitting distribution. And then we have the fitting distribution, peaks over threshold, and hill estimator. So this is about the loss from data. So in summary, we have two big aspects in the operation risk. One is the liquidity, and the other is this operational loss of data, and both of them are quite important. But liquidity risk is bit intuitive. This operational loss data becomes a bit tough because most of the things are taken from research paper and they are relatively new. Okay, in the next session we are going to look at BASEL 2, but I'm going to introduce you towards what we have in BASEL 2 in the operation risk part. So we have these three things for the credit risk. We have the standardized approach, internal rating mechanism, a foundation, and advanced. So broadly this is the first part, three pillars, and then in a sub part of this, to find out credit risk, we have these three approaches. So the three pillars are minimum capital requirement, supervisory review, and market discipline. And then we have the 3-tag capital system, and these are the three options for credit risk. So 3 is kind of a figure that is being repeated in a lot of places in BASEL 3. Okay, in the next session we are going to again look at loss of data in a more detailed way, BASEL 2 and 3, risk aggregation, and the enterprise risk management. So I hope you found this small video important. To quickly revise you, the two important things that you need to look at is liquidity risk and the distributions and the fittings and the analysis used in the operational loss of data. The liquidity risk has exogenous and endogenous risk, and these distribution from loss of data has become more important because of the complex information systems that we have, and it requires a lot more research. So that would be it for this session. I'll try to upload some of the other details about loss of data in a more detailed way, because that is not found easily on internet, whereas you can find a lot of material on BASEL 2. Thank you for listening to my video, and best of luck with your preparations.